Hello and welcome. My name is Dr. Garrett Ashbrainer with the University of Georgia Poultry Science Department. In today's presentation, I'm going to be talking about my doctoral research, where we looked into giving broiler chicks dark periods from day of placement. And so in today's presentation, I'm going to be trying to tell a little bit of a story. I'm going to start of where we started with this research, and then the progression of it, and then where we ended up with this research. And to start off, kind of comes down to how I got to University of Georgia. So I was a broiler farm manager back in Texas, and I had the opportunity to go to grad school at University of Georgia Poultry Science Department. And so when I arrived at UGA, I was working under Michael Zarek and Brian Fairchild, and they gave me a lot of autonomy. They told me to go out in the field, dig into the literature, and try to find, um, a novel project to do your dissertation on. And so somewhere around that time, we were sitting around a conference room table, and we were talking about presentations and looking at graphs and stuff. And we came across this graph. And so this is hourly water usage over 18 different chicken houses across 8 farms. And so historically, with mechanical water meters that aren't quite as sensitive, we haven't been able to detect the low flow water usage from chicks at placement. We have pretty novel ultrasonic water meters now that are very sensitive, and that we can start detecting water usage, around 30 minutes after chicks are placed. And looking at this, so what we see here is hourly water usage on the vertical axis, and we have day of age on the horizontal axis. And what we see here is after placement, we see a pattern in water usage where it goes up during the day, down at night, up during the day, and down at night, up during the day, and down at night again. And so if we look into it a little bit further, when we get past 5 days, that pattern kind of dissipates. But it got me to thinking. So we see these natural patterns in water usage after the birds hatch, even though we're giving them 24 hours of light. And so that got me to thinking of circadian rhythms, those rhythms that all life on Earth exhibit, that are based off a 24-hour period. Whether you're a bacteria, a plant, a chicken, or even a human, you're influenced by circadian rhythms. And so, thinking of it a little bit more, light is the greatest influencer of circadian rhythms. The light dark cycles of the sun, or artificial light too, are what kind of get circadian rhythms going. They're the greatest influencers, and we see these patterns. We see these day and night patterns in chicks' water usage, and we can associate that with a little bit of behavioral patterns, even though we're giving chicks 24 hours of light. And so it kind of got me to thinking that why actually do we give chicks 24 hours of light during brooding, or at least near continuous light? That when you start talking to people, it's kind of assumed that chicks will eat more feed, or some people think it's kind of a remnant of older times when we had our older chicken houses that weren't quite as tight, that it was a little bit harder to completely control the environment. But we gave chicks 24 hours of light, so chicks wouldn't get caught in a cold spot within the chicken house when the lights turned off. But it kind of got me into a mood to read about lighting programs, and really diving into the literature, really digging into the lighting literature to see where the evidence for continuous lighting during brooding comes from. And when you actually get really deep into the literature, there is essentially no research or at least there was no research when I started this project to sit there and show that um, giving continuous or near continuous light during brooding was an effective practice. That there was no evidence that it made them eat more feed or anything like that. We have these standard practices of giving them continuous light or near continuous light, from anywhere between, 3 to 7 days, or maybe some brooding periods go a little bit longer. But still, we can say we give, almost 24 hours of light during brooding. And what I've actually found was fascinating, that when you look into the old poultry books, people have been debating giving chicks 24 hours of light during brooding, since the early 1900s. So that being said, that led to a series of studies that I ended up turning into my doctoral dissertation. It was a series of 12 individual trials that ended up composing of 4 different studies, looking at either 4 or 6 hours of darkness at varying flock lengths, and then we finished it out looking at this in a commercial broiler flock. So kind of, our general objectives, that we really just wanted to see what happened to chicks if we gave them 6 or 4 hour dark periods during the first week of age. And we raised some of these birds to 14 days, some of them to 21 days, and some of them to 42 days, depending on the study. So it was really, we just wanted to see, how birds responded to the dark period during brooding. And so, to give you a little bit of an idea of how we designed this experiment for our control birds, what we did is we gave them 24 hours of light for the first 7 days. And the night of the day 7, we in study 1, we gave them 4 hours of darkness. And then we kept that, 4 hours of dark, 4 hours of light from days 7 to 14. For our treatment birds, what we did is we gave them the 4 hours of darkness, 20 hours of light from day 0, day of placement, to day 14. We set them up into different rooms. So there was 6 total rooms. 3 were set to treatment, 3 were set to control. We had multiple pins per room to be able to study this. And if you're looking at what our experimental unit was, room is our experimental unit. So the data that we collected for this, our performance was going to be body weights and feed conversion ratio, and we were able to track that at days 0, 3, 7, 10, and 14. We also took blood samples. So we did corticosterone, which that's the stress hormone in birds. So we wanted to see if either of these lighting programs, exhibited a stress response to the birds. We also looked at melatonin. So melatonin is that hormone that is highly associated with sleep. It's associated with circadian rhythms. It's associated with oxidative stress. It's associated with regulation of almost every part of the body, because it ties into the circadian rhythm. And we took blood samples on days 6 and 13. So that was the day before the days we weighed the birds. And we took blood samples then to, so our picking up and weighing of the birds didn't influence any of the blood samples. So getting into the actual data that we see, so I'll kind of go over how my graphs are labeled here. We'll see some type of performance parameter on the vertical axis. We'll normally see day of age on the horizontal axis. The yellow lines will always indicate the control birds, and the gray lines will always indicate the treatment birds. If our p-value here has a little asterisk, that means it's statistically significant, and my vertical black bar indicates the day when the control birds received their first dark period. And so looking at body weight from day 0 to 14 in the first study, so remember this is an average over 3 individual trials. What we see here is day 1, there are no differences in body weight, so we were able to evenly distribute body weights in our pens. But day 3, we actually see a significant difference. and with the control birds weighing significantly more on day 3. And that continued to day 7. So by day 7, the control birds that were given 24 hours of light ended up weighing more. And that was I was a little bit concerned about that because we were hoping that we would see the opposite. But something very interesting happened that after the control birds were given their first dark period, and when we weighed the birds on day 10, we actually see the opposite happening, where the treatment birds weigh significantly more than the control birds. So kind of exhibiting some type of what we would call compensatory growth. And by day 14, there seems to be a numerical difference, what we might call a trend here in the treatment birds weighing more, but when you look at it statistically, there was no statistical difference, that they weighed the same. So looking at feed conversion ratio from days 3 to 14, what we see is that there are no differences in feed conversion ratio between treatment and control, whether it's before or after the dark period. So that's a pretty good sign so far. Looking at corticosterone, so what we see is corticosterone that we observed during the dark period here is that we see the night of day 6, we actually see a significant difference between light and the treatment and control. Although on the night period of day 13, we did not see a difference. When we look at the daytime corticosterone, we see no differences in day 6 or 13 comparing treatment and control. And so we do see this significant difference, higher corticosterone levels in the treatment birds on day 6. And unfortunately, that was one of the first times some of our members of our lab were taking blood samples, and we have a feeling that it's one of those things that sampling error ended up coming into this, and this may not necessarily exhibit a stress response, but it may just be sampling error. But when we get into the melatonin, so remember melatonin is that hormone associated with sleep. When we look at dark period melatonin, we see on day 6 and 13 during the dark period, the treatment birds had significantly higher melatonin levels. And when we look at the light periods, we still see that significantly higher melatonin levels during the day 6 and 13, even during the light period. And so I want to draw our attention to day 13, that remember that by day 13, those birds had been on the same lighting program for 7 days. The control birds had not caught up in melatonin production, even after 6 or 7 days of being on the same lighting program. We find that very interesting. So we ended up